Okay, after you guys finish this class, you're going to take Physics 1. A lot of what you do in that class is about projectile motion. It's just about the study of motion. And the first thing you need to learn in that class is that velocity is a rate of change of position. And instantaneous velocity is the derivative of position. So if S could be my X position, could be my Y position, could be my position in 3D space. S, whatever it is, tells me my location at time t. Then the derivative of that will tell me my velocity at time t. Now, something important is happening at this moment. A lot of times in a math class, we like to let Y be our dependent variable and X be our independent variable. We're used to Y is some function of X. That says equals there. But in the real world, that doesn't usually happen. We usually don't have X's and Y's. So you got to get it out of your head that this kind of notation, when I write that means something to do with X. It doesn't always. It might have to do with T, like in this case. So in this case, V of T is S prime of T. This is the derivative with respect to time. And we could write that definition either way. We could write it just like we did above, or we could say this is the limit as h approaches 0 of s of t plus h minus s. Oh, I guess we're doing a plus h. Sorry, a plus h minus s of a all over h. Okay, so we got some position function here. That's that blue curve. So I don't know, I threw a baseball up in the air. I started here at some initial position. That baseball goes up, and it looks like up here it's starting to come back down. Then a secant line, an average rate of change, would tell me my average velocity over that time interval there. The slope of that secant line is an average velocity. The slope of this tangent line tells me exactly how fast and what direction the ball is moving at that moment. Okay, so let's look at some examples. I've got some function here. I want to find the instantaneous velocity 1 second after it's dropped. And I'm going to use the other version. We could do it this way. I'm going to use the other version of the derivative. So V at 1 is by definition the derivative of position, S prime at 1, which is the limit as h approaches 0 of S of 1 plus h minus S at 1 divided by h. Using this for S. So that'd be limit as h approaches 0. S of 1 plus h means rewrite this entire function. But now instead of writing t there, I'm going to write 1 plus h in parentheses. So all I've done right there is written S of 1 plus h minus. Now this says I'm supposed to subtract off S of 1. That's negative 16 times 1 squared plus 64 all over, don't forget the all over, h. Equals limit as h approaches 0. Don't forget to write that. All right, let's clean all this up. So negative 16, I have to FOIL that out before I distribute. And remember, that's going to be the first one squared plus multiply them together and then double it. 1 times h times 2, 2h, and then square the other one. Plus 64. And then this one we can go ahead and do. Let's see, we're going to have, that's just 64 minus 16. I think that's 48. So minus 48 all over h. Make some space for myself here. Equals. All right, let's distribute that 16 there. So I get negative 16 minus 32h minus 16h squared. And then that's going to be plus 16. Hey, look, all the constants cancel out. Everything that's left has an h in it. If something left doesn't have an h in it, you've done goofed. Because I need to cancel this h in the bottom. So limit as h approaches 0. I'm going to factor an h out of the top. I can't read my own writing there. I think that's minus 16h squared. Yeah. Oh, but I factored an h out, so only one h left there. So I pulled out the common factor of h. Oh, that cancels. Now I can actually evaluate the limit by plugging in h equals 0. So I get negative 32 minus 0, which is negative 32. Now we got to think about units. The top here, these are positions. That's measured in feet. H, those are times. That's a change in time. That's measured in seconds. Derivative is always a ratio. It's always going to have units of y per x. In this case, s per t, or feet per second. Notice we got a negative. That means that my ball that I've thrown here, or this rock, is moving down. Positive is, or up is positive velocity, down is negative. Velocity is a vector. It has direction. Okay, let's do, I don't want to do that other one. Let's do this problem here, because you might have some homework problems that kind of look like this. If you were taking a business calculus class, you would do a lot of problems like this. Okay, so we've got here, price is a function of the number we want to produce. So you choose, this is called a demand function or a price demand function. You choose how many Xboxes you want to sell, and this will spit out what price you should charge. This is my cost function. This is how much it costs. That'd be a pretty expensive Xbox, right? $100 per Xbox plus $10,000, just we call that fixed cost. That's your rent on your factory. Okay, we want to talk about profit. Well, first we need to talk about revenue. Revenue, R of X, is how much money you're bringing in for each one you sell. And that's always going to be X times P of X. So if you sell it for $10 and you sell 100 of them, then that would be 100 times 10. The revenue you bring in is the number you sell times the price you sold them at. So in this case, that would be X times negative 0.01X plus 400. And we could clean that up a little bit and see that's what? Negative 0.01X squared plus 400. And my cost, I'm just going to write it. It's given. I don't have to do any work to get this. There's my cost function. Well, then what's profit? Think about if you own a shop. This is how much money you bring in for selling X items. This is how much money you're spending for X items. Profit is always revenue minus cost. So in this case, that would be negative 0.01 x squared plus 400 minus, and then in parentheses, all the stuff, the cost function. So let's see, that'd be negative 0.01 x squared. I think we get minus 100x. And then I'm going to have 400 minus 10,000. So that's minus 9,600, I think. Yeah, because add 400 to that, that would be 10,000. All right, this is my profit function. I'm not done. I just found the function. I keep crossing through them. Okay. Now I want to know, I don't want to know what's my profit when 10,000 games are produced. See, I'm not just going to plug that in here. That would tell me how much money I make, how my profit is if I plug in 10,000. That's not what the question says. It says, what's the rate of change of profit? I want to know how quickly is profit changing at that point. So I want P prime of 10,000. So that would mean doing limit as h approaches 0 of P of 10,000 plus h minus P of 10,000 all over h. And I'm not going to go through the whole problem here. I just wanted to get this set up. Like we'll do some more examples like this later. I do want to do this problem. I like this problem a lot. Hint, hint. So I've got two different position functions here. I got my blue car. I got two cars. They both start at the same spot. The blue car is given by f of t. That tells you how far he is from his initial position at time t. And then we've got the orange car here. Okay, after 2 seconds, who's traveled further? So let's see. At 2 seconds, right there, the orange car has only gone 1 foot, because y here is measured in feet, s. Whoever drew this graph wasn't thinking. This really should say s, and this should say t, position and time. So g of 1, the actual, or g of 2, I apologize, g of 2 is 1 foot. He's traveled 1 foot. F of 2, where's he? Oh, he's up here. He's further away. He's 2 feet away. So who traveled further? F did. Now, what about the velocities at 3 seconds? Velocity is the slope of the tangent line of position. So here, let's look at F first. His tangent line, he's already linear. His tangent line is the line itself. The slope of this blue line, you should just be able to look at that and see the slope is 1. F prime at 3 is 1 feet per second. I'm going to write that here. What about on G? This one I'm going to have to eyeball a little bit. So I want to kind of draw in a tangent line here. And it looks to me like it maybe passes through that point right there. So I'm looking for the slope of this line right here. Well, that slope, if I go over 1 up 2, I would hit another point. It looks to me that G prime at the value 3 is about 2. So I'll write that again here. G prime at 3 is about 2 feet per second. So G is moving faster. Even though F has moved farther at that point, look, F has moved about 3 feet away. G has only moved 2 feet away. F has moved further, but at this moment, G is moving faster. Similarly here, look at 4 seconds. G's tangent line is much steeper than F's. G prime of 4, I think you would have to agree with, is much bigger than F prime at 4. So G is moving faster. At that moment, remember we're talking instantaneous. Now, how far have they traveled? Well, look, right, they're going to run into each other. After 4 seconds, they've moved exactly the same distance. They're both 4 feet away from the origin. So they've moved the same distance. Okay, that's a good place to stop here.